To address the core issue of generating diverse robotic maneuvers, based on human intent and drone aerobatics, Professor Gao Fei's team from the School of Control Science and Engineering at Zhejiang University published a study in the top robotics journal Science Robotics. The study proposes a complete autonomous flight system, which innovates in the aspects of instruction, planning, and control. The system enables drones to generate and execute complex robotic maneuvers in cluttered environments, achieving performance comparable to professional pilots without manual operation. In real-world experiments, the research conducted robotic flight experiments in a large-scale and structured environment, where the system generated trajectories based on robotic intentions, and strictly controlled net thrust and angular velocity, within dynamic limits to ensure easy execution of maneuvers. Furthermore, the successive robotic maneuvers experiments were conducted in a confined space with a height of only 3.5 meters. NOKOV Motion Capture System was used to obtain the high-precision, real-time data of robotic flight trajectories and attitude of the drones. The results showed that even with closely spaced user inputs, the system could automatically adjust and successfully complete the robotic flight tasks in confined spaces. Additionally, the autonomous system proposed was compared with a professional human pilot, with 5 years of flying experience. The results showed that the system achieved a 100% success rate, which outperformed the professional pilot.